All right, welcome back. The last time we solved our grid traveler problem and we discovered that it was working fine. But now we have more and more examples that we can run our grid traveler function on. Sorry. More examples. Okay. Our traveler had double L. Double L. Okay, double L. Okay, now let's save it. Let's go to our command line and let's go. Good. But as we can observe, we saw one time, two times. So the grid traveler of a 1 by 1 takes one time. The grid traveler of a 2 by 3 takes three times. Of a 3 by 2 takes three times. And of 18 by 18 and 20 by 20 is not outputting and is taking almost forever. Let me minimize this so that we can also see. Okay, minimize. Okay. Let's kill that. All right. So we can clear our screen now, and let's go back and see what we can do. Let me make the terminal window as the same. Let me reduce the size of the terminal window so that we can see alongside. Right. Let's be here. Right. So now our task is, if we check our function, we discover that we have two recursive calls side by side. And with these two recursive calls and with the tree going through every single loop, we have our code running on exponential time. And this is not so good. Can we do something about it? Yes, we can do something about it. We'll use a method called dynamic programming. Either we use memoization or tabulation. But here, we are going to start with memoization. Maybe in our future classes, we are going to deal with tabulation. Memoization is just a technique where we create a map. Instead of executing every single call, we store our results in the map that we have created. Let me put it here. Let me create a memo object. Memo object, and let me store the map inside of the memo object. Now what we can do is to check first if m comma n, if m comma n, if our parameter is not, if it's not in memo, then we execute these functions. If it is not in the memo, then we execute these functions. Then instead of returning now, we can now put our grid traveler into our memo object. So we can say memo, memo, memo m, n, update it. And after that, we can return everything to our function. All right. So for that, let's indent. But Python is a language that indentation is really key. So we have to indent. Let's see everything here. Indent. Oh, it's not working. Oh. All right. All right. And all right. So then we can return our memo object, memo and from in save it. Okay, we can edit it there. So at this point we can what else can we do? Okay, we can pass in our memo object here. Memo. Everything is clear. Gotta come here and all right. So everything is fine. Let me move this. Good. Everything is fine. Let's save this and let's try running it out in the command line in our terminal window. Beautiful. Voila. Wonderful. You see, it's just instantaneous. Therefore, we have one way we have been able to optimize our code to ensure it runs on linear time, because every function call is called once and no longer twice. If it's to be called twice, instead of it to be called twice, the memo object releases its own value that is stored in memory. Wonderful. Thank you for being here with me. See you next time.